Let the recording start, then we'll start the lecture. Yeah. Good afternoon, students. We'll first revise what the topics that we have done yesterday, and then we'll go to the new examples. Just a second. Yes. So yesterday we started with order and degree of the differential equation. Then we also saw what we mean by formation of differential equation. I'll take one or two examples more of formation, and then in the classroom, Anuja will be taking the further topics. Okay, of formation of differential equation. So let me just ask you the few questions related to what topic we have done yesterday. Who can tell me what is order of a differential equation? Yes. What is order of a differential equation? Roll number.
Order of highest derivative.
Yeah. Vaishnavi, correct. Roll number 1 is present. C division today. Jay. Jay, are you present? Jay Admani. Okay. Roll number 2, Palak, you are present?
Yes, ma'am.
Yeah. What is the order of a differential equation?
The number of time it is differentiable, that will be the order of that equation.
The highest order of the derivative, you mean to say.
Yes. Yes,
Yeah.
ma'am.
Okay. And what about degree? What do you mean by degree of the differential equation?
Power of order.
Power of the highest
order.
Power of the highest order. Yeah. But the differential equation should be free from
Fraction.
fractions,
Fraction, radical,
Constant
and integration also.
integration also.
Okay. Then what do you mean by formation of differential equation? Or before that, what is the meaning of solution of a differential equation? Roll number 22, division D. You are present, Aditya. D22, Aditya. Dairude. Aditya Dairude. Then who else? Roll number 5, division D, Kavita.
Yes, ma'am.
Yeah. What do you mean by solution of a differential equation?
It, like steps, you want the steps, how we find the solution.
No. What do you mean by solution of a differential equation?
So, sorry, ma'am, I can't remember the definition.
No, in general, you tell them what is. There is nothing like definition. If you have a differential equation, what do you mean by
Ma'am,
solution?
it's free of radicals, fractions, and integrations. Like
That is the differential equation. Suppose you have differential equation dy by dx is equal to 1 by x. Then what do you mean by solution of differential equation? Tell in your simple words. No need to tell hardcore definition. If dy by dx is equal to x, then what do you mean by solution of this differential equation?
Function that satisfies the differential equation.
Yeah, the relation between y and x, which will satisfy this differential equation now. Isn't it, Kavita? Dy by dx is equal to x. So I am asking you solution of differential equation. I said no.
Relation between independent and dependent variable.
Correct. And general solution is the
Relation
one which.
between independent and dependent, which has arbitrary constant equal to the order
Very
of
good.
the
Very
differential
good.
equation.
Excellent. If the order of the differential equation is 2, then there will be how many arbitrary constant?
Two arbitrary
Two
constants.
arbitrary constant.
Two arbitrary
Yes.
constant.
Yes. Now this, if you know this in when you are doing the definition, when you are writing the solution of differential equation definition, if you that is a general solution. So relation between the dependent and independent variable having arbitrary constants equal to order of the differential equation is said to be general solution of the differential equation. And what do you mean by particular solution?
When C1 takes a
When the
particular
arbitrary constant is
value.
0.
C1 takes particular value, then
Yes,
it's called
yes,
particular
0.
solution.
Correct. If it is 0, then it is one specific. Any fixed constant. If it takes that arbitrary constant which is there, C, if it takes a fixed value, then it is called as particular solution. Okay, so that's those are the things that we did, and we did formation. So we did one or two example. What do we mean by formation of differential equation? For that, you will be given the solution of the differential equation. General solution will be given, and what you have to do is, from that general solution, you have to form the differential equation. So how do you form the differential equation? Can anybody tell me?
There are 3 steps.
Yeah,
First is that we identify, in the general solution, we identify the number of arbitrary constants.
yes,
Then we differentiate the given solution with the number of times is equal to the number of constants.
yeah,
And then we eliminate the arbitrary constant using the derivative equation.
very good. So these are the 3 steps. Number of arbitrary constants are identified. So there are 2. Then you will differentiate twice the differential given equation, general solution. After that, we will try to eliminate. The third step is eliminate those arbitrary constants, so that we will get an equation which will have derivatives, which may have dependent variable and independent variable, but no arbitrary constant. That particular equation is called as the differential equation, whose general solution will be given to you in the question. Okay, so now let us do one or two examples on that more quickly, and then we'll go to the second part of this unit, that is solution of differential equation. So first is to take down the question. First, sometimes the question will be not directly that form the differential equation whose general solution is so and so. It can be given as a general statement which has some data. From that data, you have to form the equation, which will be the general solution, and then form the differential equation. So take down. Form the differential equation. The question is, form the differential equation of all circles which touches the y-axis, and has center lying on x-axis, So for that, what you have to do? First, you have to form the equation which is satisfying the given condition. That is the general solution. Okay, and then for this particular general solution, what will be the differential equation? It's not at all difficult. Whatever we have said just now, that is a family of all circles which is touching the y-axis at origin, and center is lying on x-axis. Then how do we go about it? So let us just try to draw this first. Okay. So what will it be? This is your y-axis. This is your x-axis. Now try to draw the circle which is touching the y-axis at origin. So here the circle should be touching, and the center of the circle is on x-axis. Any point on x-axis. How does it look? Some point a comma 0, na? Yes or no?
Yes.
Yeah. So the circle will be something like this. Trying to draw something. Don't think that is an ellipse. It's a circle itself. Okay. So the circle will be like this, and this is one circle. And how it will change depending on this A. So A is the arbitrary constant. It can be 1, it can be 2, it can be -1, it can be -2, and so on. So these are all possible set of family of circles touching the y-axis at origin and having the center on x-axis. Okay. So how do we represent this circle? Can anybody tell me? Yes, Abhimanyu, you are there. You can say. Abhimanyu, roll number 22, you are there, present. Sunil, PA.
Yes, ma'am.
Yeah.
X minus a square. X minus a square. A square.
A, the whole square, na?
Yes, ma'am.
Yeah.
Plus y square
Plus y square
equals to a square.
is equal to.
A square.
Is this clear to everyone why we are getting it? This is the equation of the circle in center radius form. If your center is f comma g or a comma b, the end radius is r, Then the equation of circle in center radius form is x minus a the whole square plus y minus b the whole square is equal to r square. This is your equation of the circle in center radius form. So what is the center now? A comma 0. So A remains A, and what is B is 0. So y minus 0 the whole square is y square. And what is R? R is this radius now. So what is that? This is the distance of the circle from x-axis, which is A. So your radius is A. So that's your equation. So first step is form this equation, which is this is the general solution. This is called as G dot S, GS, general solution. Now you have to find which is the differential equation, which we have this equation as its general solution. Clear? So this was one step before. The equation was not given. General solution was not given. So we formed the general equation, and now we will go to the steps which are just now the student told. What's the first step? Identify the number of arbitrary constants. How many arbitrary constants are there?
One.
One. There is only one arbitrary constant, which is A. Why it is arbitrary? Because radius can change. Is A. Okay? And therefore, what will do the step 2? Differentiate
once.
the given
The
equation
given equation.
with respect to which variable? With respect to which variable you are going to differentiate? X.
X.
Yeah, X. So first we rewrite that equation in a more simpler way, because you can see a square here as well as a square here. So let me write it. X minus a the whole square formula is x square minus 2ax plus a square plus y square is equal to a square. So this a square cancels, and your actual equation is x square plus y square minus 2ax is equal to 0. Okay? So this is the equation 1. Now differentiate that with respect to x. 2 will become 2x. Derivative of x square with respect to x is 2x. Plus derivative of y square will be
2y
2y
by dx.
divided by x. I'll write it as y1 so that it looks simple. Okay? And then minus 2a.
2a.
Minus, na?
Yes, ma'am.
Yeah. Minus 2a, that is equal to 0. Now you can see everywhere 2 is common. Or if you want, you can keep 2a like that only. So that what you get? The a is eliminated.
A
Is
equals to x plus y divided by dx. A equals to
Yes, a is not eliminated. So you have to eliminate a. So get the value of a. If you want to cancel, you can cancel out 2. So it will be x plus y y1 is equal to a. Put this value of a in your equation 1, and that is your final answer. Then put, so third step. Step 3, put a in 1 so that we get x square plus y square minus 2x into a is x plus y is equal to 0. So you simplify this because you can see x square term and there is one more x square term. So it is y square, x square, this is minus 2x square, so minus x square minus 2x y y1 is equal to 0 is the required differential equation. Clear? As simple as that? Okay. If you want to please write down this one, what we are doing in the class simultaneously. So x square plus y square. Yeah.
ही एक स्टेप नाही समजली.
Last one.
नाही सेकंड इक्वेशन मध्ये बघा तिथं आपण डिफरन्शिएट केलं ना 2x वाला.
This one x plus y
मॅम ते
y.
2y y1 कसं राहते y1 म्हणजे काय ते नाही लक्षात आलं.
This is the equation. My equation is the equation 1. X square plus y square minus 2x is equal to 0. This is the equation 1. We have differentiated this with respect to x. So what's the derivative of x square? It is 2x.
2x.
Okay. What's the derivative of y square? Y has inside x. Y is depending on x. That is the way we are considering it. That's why I'm differentiating with respect to x. Okay. So what's the derivative of y square first? 2y into derivative of y with respect to x.
Okay.
So we are differentiating with respect to x. मग y x कशाला पाहिजे होता ना जर y1 लिहिला.
अच्छा मॅम म्हणजे ते आपण dy by dx लिहितो तुम्ही ते y1 लिहिलंय.
ते सांगितलं मी मगाशी. I am writing for making it look simple y1 in place of dy by dx. You can write dy by dx.
आलं लक्षात.
Okay.
dy by dx as y1 लिहिणं म्हणून जरा confused.
Correct. So x plus, because this notation will be there in your papers also, MCQ pattern also. Okay. So it can be sometimes dy by dx, it can be sometimes y1. So you should know all those notations. Okay. So it is x plus y by 1, cancel it out in 2, you get the value of a. Put that value of a in your equation 1. A is eliminated and you get the required differential equation. Clear? Everyone?
Yes, ma'am.
Okay. So if you have finished writing, I'll give you one question to try to solve it, and many more questions along with MCQ will be done in the flipped classroom. Yeah. Then, should I give you the next question?
Yes, ma'am.
Wait
Yes, ma'am.
2 minutes.
Yes, ma'am.
Okay. I'll write it. Those who have finished can start, and the others you can start after you complete it. No problem. I'll give you time. Okay. Form the writing it also. Form the differential equation whose general solution is x is equal to c1. Let me check the question now. C1 e raised to t plus c2 t e raised to t. X is equal to c1 e raised to t plus c2 t e raised to t. There is a very specific reason why I am taking this example. Can anybody guess why?
Because there is b constant.
Two arbitrary constants.
Two arbitrary
Yeah,
constants.
that is one of the things. There are two arbitrary constants. Anything else?
There is e raised to t. We can multiply e raised to minus t both sides.
There is an exponential power, so we will multiply by log c like.
A lot will be more complicated because
We had
t is
Ma'am,
E raised to
so
minus
e raised to
t.
ma'am, e
minus
raised
t
to
is one of
minus
the
t. We can multiply both sides, ma'am.
correct. Yes, that is one of the things. But actually, what happens? The reason why for taking this example is generally you are used to taking the variables x and y. Okay, and suddenly if the variables change, then you don't understand with respect to which variable you have to differentiate. Those are very clear with the concepts, no problem for them. But the other students, they generally think that x is always the independent variable and they go for differentiation with respect to x only. But here, who is the dependent variable and who is the independent variable?
This is a dependent and
He is independent.
t is
Yes,
dependent.
t is dependent.
X is
Independent,
X
not
is independent, X is dependent.
Is independent.
X is depending on t, so x is dependent variable and t is independent variable. Are you getting it?
yes, ma'am.
Okay. So
Yes.
therefore, what we are going to differentiate with respect to?
T.
With respect to t. So differentiation is with respect to t. Is this clear to everyone? ज्यांना फार पटकन समजत नाही त्यांना समजलंय का? X हेचं रिलेशन t मध्ये दिलेलं आहे. So x is depending on t. X is depending on t and differentiation is always done with respect to independent variable. So you have to differentiate with respect to t. So dx by dt, you get dx by dt. Okay? Fine. So now let us start with the steps. The first step is identify the number of arbitrary constants. Those are 2. Then step 2 is differentiate this equation 2 times and try to eliminate. You can go for determinant method or you can directly go for elimination. I would suggest go for elimination by direct substitution.
Ma'am,
Yeah.
answer is d square x by dt square minus 2 times dx by dt plus x equal to 0.
D square.
D square x by dt square minus 2 times dx by dt plus x equal to 0.
Correct. Is equal to 0 or C? Yes, equal to 0. Right, absolutely. Correct. So step 1, I'm writing it slowly. Step 1 is there are 2 arbitrary constants C1 and C2. Step 2, differentiate. This is the equation 1. Differentiate 1 with respect to t once. First time. So you get dx by dt is equal to c1 e raised to t, and it is because derivative of e raised to t is e raised to t. C1 is the constant, plus C2, or T into e raised to t is product rule. Derivative of t is 1, e raised to t as it is, plus C2t as it is, derivative of e raised to t is e raised to t. Now, if you take one more derivative, it will keep on increasing the number of terms. So, here only you simplify and write it properly. So, what it will be? This is C1 e raised to t plus C2 e raised to t plus C2t e raised to t. Now, you just see if I combine the first and third term, it is same as x. C1 e raised to t plus C2t e raised to t is same as x. So, this is nothing but x plus C2 e raised to t. Dx by dt. Clear? So your equation is looking very small. Otherwise, it will just keep on increasing the number of terms and then you have to substitute at the end. Rather than that, this will be a better way of doing it. So this is your equation 2 now. But you have differentiated only once. So you differentiate it one more time. Therefore, differentiating 2 again with respect to t, you will get d2x by dt square is equal to derivative of x with respect to t, that is dx by dt, plus c2 e raised to t. Derivative of e raised to t is e raised to t. But since c2 is there, so from here we get the value of c2 e raised to t. So dx by dt minus x is c2 e raised to t. So put 3 in 4. This is step 3 now. Put 3 in 4 to eliminate C2. So what do you get? Into x by dt square is equal to dx by dt plus dx by dt minus x. That's the value of C2t. And combining all the terms together on the left hand side, or taking all the terms on left hand side, e2x by dt square minus 2 dx by dt plus x is equal to 0. This is the required differential equation. Clear? Everyone?
Yes, ma'am.
Okay. So this will help you to understand how we form the differential equation. There may be some complicated equations also. Those also I give you, as well as more MCQ questions also I share with you. Now let's go to the next topic. Everyone, is it? Yeah.
Can you explain it again?
Yes.
Yes, ma'am.
Okay. Fine. So look at this equation. X is what is given to you. You have to form the differential equation. Whose general solution is x is equal to c1 e raised to t plus c2 t e raised to t. So the
Screen is
first
not visible.
I have shared it. Everyone, please.
Ma'am, it is blur.
No, ma'am.
Yeah, it's
No, ma'am, we
No,
can
ma'am,
see it.
it's very very clear because this is the best camera that I could find in the entire college type, and I have selected that one for you. Maybe there will be internet issue from your side. Okay. So whatever I am saying, please listen to that and try to write it simultaneously. Then you'll understand. Okay. So you have to form the differential equation whose general solution is x is equal to c1 e raised to t plus c2 into t e raised to t. So c1 and c2 are your arbitrary constant, and the functions which are there are e raised to t and t e raised to t. Okay. So have you written that equation?
Yes.
Yeah. Now, if you want to form the differential equation, you have to first identify who is independent and who is dependent variable. Because with respect to independent variable, you want to differentiate. So, x is depending on t. So, therefore, you have to differentiate with respect to t. That's the first thing to understand. Secondly, how many arbitrary constants are there? C1 and C2 are 2 arbitrary constants. So, minimum you have to differentiate twice. So, your first equation, when you differentiate it once, you get derivative of x with respect to t is dx by dt, which is equal to c1 is constant, it will remain as it is. Derivative of e raised to t is e raised to t because I am taking it with respect to t. Okay, plus c2 is arbitrary constant, it will remain as it is. Here I have product of two terms, p into e raised to t. I have to use product rule. What's the product rule? Take the derivative of first one, keep the second one as it is, and then plus keep the first one as it is, take the derivative of second one. So I have taken the derivative of t with respect to t, that's 1 into e raised to t plus c2 as it is, t is kept as it is, derivative of e raised to t is e raised to t. Okay, now there are three terms. If I solve this or if I differentiate this one more time, I'll get 4 terms. Rather than that, what I will do, I'll see whether I can substitute for the values which are on the right hand side with the help of equation 1. So it becomes simple. Look at equation 1, c1 e raised to t plus c2 t e raised to t is x, which I have here. c1 e raised to t, c2 t e raised to t. So combining the first and third term, it is x. Keep the middle term as it is. X plus c2 e raised to t, which is equal to dx by dt. Now, get the value of c2 e raised to t because you require it earlier. So what is that? Dx by dt minus x is c2 e raised to t. I have differentiated only once, but how many arbitrary constants are there? 2. So I have to differentiate it one more time. So let me differentiate this equation 2 one more time. So derivative of dx by dt with respect to x with respect to t means what? Apply dy dt to this equation. So it will become d to x upon dt square is equal to derivative of x with respect to t, that is dx by dt, plus c2 as it is, derivative of e raised to t with respect to t is e raised to t. Okay, now everything, this first left hand side and first one on right hand side is derivative, but c2 is still remaining, so I have to eliminate it. For that, I have rewritten this equation 3. So put the value of c2 e raised to t here, it becomes plus dx by dt minus x. Combine all the terms. These are 2 times dx by dt, which I take on left hand side, it becomes minus x becomes plus, and that's a differential equation which is free from arbitrary constant, has derivatives and dependent independent variables. Okay, clear now everyone?
Yes, ma'am.
Okay. So that is meaning of formation of differential equation.
Ma'am,
Now, yeah.
if we multiply with e to the power minus t, then it takes much less time that.
Sure, now you can go for that. C1 will be allowed. That is also fine. Now. This is one way that yesterday I told that way. Na? So I have told this by back substitution. All possible methods, whichever becomes simple for you. So if you multiply by e raised to minus t, you will get x e raised to minus t is equal to c1 plus c2 t. Then when you take the first derivative, c1 will go, and when you take the second derivative, c2 will go. But on left hand side, you have to apply the product rule properly. Still, you get the same result. We can do that, not a problem. Is it okay?
Yes, ma'am.
So that is about formation of differential equation. Any doubt to anyone? Still, you can please ask because everybody will get minimum one question of formation in your final university exam also, and it may be so long also. So generally, when you see what is the hint to get the number of steps less, if your question has e raised to t term on right hand side, go best way by e raised to minus multiplication. Then your number of steps will be less. If you have x square by a square, y square by b square type of term, then differentiation and substitution of a square by b square or b square by a square will become easy. If suppose you have cos and sine terms, then back substitution will be simple because derivative of cos becomes sine and minus sine, and derivative of sine becomes cos. So back substitution becomes easy. So trigonometry, and if upon is your constant is upon, then also use the equations which you are getting by differentiation to back substitute like we do. Is it okay? Everyone?
Yes, ma'am.
Okay. Fine. So,
Yes,
so that is about formation of differential equations. Again, I'll ask you just one simple MCQ. Just tell me whether you are able to answer this. Okay. Number of arbitrary constants in the general solution of n order differential equation are given the options. Do you understand the question what I asked you? Number
N,
of,
ma'am. N.
yeah, very good. This question lasts for 1 mark. Okay, till earlier it was last for 1 mark. Again, this time also it will be there. So that's the easiest question which can be asked. number of arbitrary constants in the general solution of a differential of nth order differential equation will be n. Okay, so they say less than n, cannot be determined, or at least n. Okay, then equal to. The answer is equal to, not at least n. Okay, right?
Yes.
Fine. So now let us go to the second part of differential equation, that is solution of differential equation. Solution of differential equation. So to find the solution of differential equation, first we have to identify what is the type of differential equation. Okay? And before going to the type of differential equation, let us see which type of differential equation we are going to solve here, at least in MP. Okay? So we are going to solve, looking at the various types, you'll understand if first order, first degree only has these many types, then second order, second degree and all, how many various types will be there and how we are going to solve. Okay, so that will be totally taken up in M3 first unit. Now in this unit we are going to do only first order and first degree, the differential equations which is of first order and first degree. Only those type of differential equations we are going to see. So can anybody give me some simple example of a differential equation which is of order 1 and degree 1?
dy by dx is equal to sin x.
dy by dx equals
dx.
to
X, I'm writing comma, sin x, and so on. Okay, so dy by dx, how many times the differential equals? So the order is 1. And what is the power of that? That is also 1. Is it clear? So this is first order, first degree differential equation. So looking at this, you think it is so simple. Okay, now it is so simple because this is actually easy to solve. Because I write dy on one side, x dx on the other side, and get the answer. But there are a variety of types of differential equation which are of first order, first degree, and then we have to see the solution of it. Whether it is variable separable, whether it is variable separable after substitution, homogeneous, non-homogeneous, exact differential equation. I write down those types. If you want, you can write down. So first of all, let me write how the general form of first order, first degree differential looks like. So it is this way. M function of xy plus n function of xy. Most general term, dy by dx is equal to 0. Or m dx plus n dy is equal to 0, where n is a function of xy, n is a function of xy. So the most general form of differential equation of first order, first degree is nothing but can be written as m dx plus n dy is equal to 0, or mxy plus nxy divided by dx is equal to 0. You can see that this dx is multiplied, and this is said to be the most general form of first order, first degree differential equation. Okay, so you can write that. The general form of first order, first degree differential equation is given by nxy plus nxy divided by dx equal to 0, or m dx plus n dy is equal to 0, or m dx plus n dy is equal to 0. That's the most general form of first order, first degree differential equation. Now, when we want to solve this, if that n becomes only function of x and then n becomes only function of y, then how will you solve it? Can anybody anything? What I am saying, just listen carefully. So m if that becomes just a function of x, in the first one I have written mx comma y. It's what? It can be x and y both. So if it is both, then this dx, how we are going to solve it to get the relation between y and x will become difficult. But if this m is only function of x and this n is only function of y, then how can we do the solution? How can we find the solution?
Integrate simply.
By integrating.
Just integrating. Just by integrating. So that is nothing but it is called as variable separable. So I can separate out dx along with the functions of x, dy along with the functions of y, and that is the meaning that we can separate out the variables and solution will be just integrated. And when you are doing integration, there will be constant of integration plus c. That will be the solution. So that is type variable separable. Okay. Now sometimes it is not directly variable separable, then you have to do some substitutions and get it converted to variable separable. For example, say that dy by dx was not sin x but dy by dx was sin of x plus y. Then what you will do? That x plus y is making the problem, because we have to, even if you use the formula sin a plus b, okay, then what will be the formula that you will get? You will get sin and cos with x and y, sin and cos with x and y. So it will be a, you cannot take anything common, and you separate them variables. If you are able to separate them, fine. Else, what's the second way? Put x plus y is equal to the variable u, and you will get a variable separable equation in u and x. Solve that for u and x, and back substitute the value of u, that will be final answer. So that is type 2. Variable separable, reducible to variable separable after substitution. Okay? So let us write down those forms. Write down the form types. The various type of differential equation of first order first degree. Obviously, that we are going to study are first one, variable separable. Second, reducible to variable separable. Variable separable henceforth can be written in three orders. Okay, reducible to variable separable by substitution. Third is homogeneous and both are writing together. Non-homogeneous differential equation. This non-homogeneous will be converted to homogeneous and solved. Okay. Then fourth is this are done, homogeneous, non-homogeneous. Then there is something called as exact differential equation, and the second part of it is non-exact. Again, what do you mean by non-exact? It won't be exact, but I will convert it to exact and solve with the help of integrating factor. Using integrating factor. And then linear differential equation of first order first degree. And last one is reducible to LDE, linear differential equation of first order first degree. So these are the type of example, type of differential equation that we have studied.
Equation.
Reducible to LDE, which is there, that is one modus. So in that there are two types, either by substitution of x raised to n dy by dx in terms of a new variable, or f of x in terms of f of y, f of x in terms of a new variable. Those are called as Bernoulli's differential equation, which are reducible to linear differential equation using the substitutions. And those substitutions are fixed.
And fourth one.
Linear differential, exact differential equation is rather again easy, like variable separable. Non-exact again is 5 types inside it. So you can just imagine first order first degree only. These are basic, straightforward 6 type, 7 type rather. And in this non-exact there are more 5 types. So there are how many? 10 around. Okay, and still some of them are not being able to bend down in these types. And for that, numerical methods are used to solve the differential equation by integration. Okay, so that again you are going to do in M3. So there are restrictions for solving the differential equation of first order first degree only. If they are not fitting into this, then you have to go for solving it by numerical methods. Euler's method, Euler's modified method, Differential method, and fine. That you are going to do in your M3. Right, so these are the types. So let us start with one by one actually, and once we complete all of them, then I'll give you all mixed questions. So there it will be a task for you all to identify whether it is type 1, type 2, type 3, type 4, and then get the final answer. Okay? So let's start with first one. I'll do only few again because Aditya is going to take more deep concepts of variable separable in his fifth class. Okay? So let me write down the basic form of variable separable. differential equation. So dy by dx, what we had written? M xy plus N xy dy by dx was equal to 0. This was your first order first degree differential equation. Now I want to make it variable separable. So this should become dy by dx should become of the type some function. Don't get confused whether that and this is same and write it as m1. It can be either m1 by m1x upon m1y. So that what it will get converted to? It will become m1y dy is equal to m1x dx. Are you getting it? So it is separable, variable separable, and just doing the integration of this plus c will give you the final answer. Yes or no?
Yes, ma'am.
Yeah? Or it can be, is there any other way, is there any other form that?
Negative sign, no?
Yeah, that's what I said. If this I would have written m, then that m would have gone on this side and it would have become minus. So I have written m1. So it's totally a new function, then I take it on this side, it is minus and only function of x, that function entirely I have written as m1. Is it okay?
Yes.
Right. Or it can be, is there any other way to represent it? यहाँ पे हम लोगों ने x का function numerator में और y का function denominator में लिखा. Can it become reverse? This can be only function of y, na? And this can be a function of x. Yeah, so that is also possible. So or dy by dx can become some function m2 of y upon some function of x. This also can happen. Then what will it reduce to? It won't reduce directly to dy into y term and dx into x term. It will become dy upon m2 of y is equal to dx upon m2 of x. And again you can do the integration plus this I'm telling you the general form, so you see the examples. Is this clear? So when we say it is variable separable, either dy by dx is function in x upon function in y or function in y upon function in x, and then we can separate it out dy along with y function and dx along with x function either in product or in ratios. Okay? So this type of questions also can be there for your MCQ 1 mark. That's why I'm giving you all these things. Clear?
Yes, ma'am.
Yes, okay. So you please write down this. Now we'll go to the examples. Take down the question. Now the question will be like this: solve x cos y plus sin y dy by dx is equal to 0. X cos y plus sin y dy by dx is equal to 0. I will give you two questions. The second one is dy by dx is equal to e raised to x minus y plus x square e raised to minus y. So looking at the question directly, you cannot say that it is variable separable, but you can think whether I can separate out the groups. That is the thing we have to identify. Look at the first question. X cos y plus sin y divided by dx is equal to 0. So
Divided by cos y.
Yes.
Divided by cos y.
Yes, you can divide by cos y. So it is x cos x plus sin y by cos y dy by dx. And then this dx will be here. That is equal to. So it is variable separable. Can you see that? Everyone?
मैम यूवी रूल से हम कर सकते हैं ना इसे?
Yes, if you can see clearly that the derivative is d of something product, then you can do it. अगर directly दिख रहा है. You are saying that after this you have to do by u into d rule, ना?
Yes ma'am.
Yes,
After
yes,
VS फॉर्म निकलने के बाद.
बराबर उसी से करना है, लेकिन sometimes when you said that what strike me was looking at the equation, if you are able to understand that this is d of x cos x sin y, something like that. Are you
Yes,
getting
ma'am.
it? Then
Yes,
directly
ma'am.
you write that integration is your answer. So that is called as method by
मैम
code.
मेरा आंसर
हाँ, क्या है
x
आंसर?
sin x minus 1 minus cos x plus 0 equals to minus log sec y plus c.
I think so. That is correct. You got a constant term.
हाँ मैम.
Okay. Remaining students also please try. Let me
Ma'am,
see.
it is x sin x plus cos x plus ln sec y plus c equal to c.
Yes, yes.
Yes, ma'am. That also mine also that come.
That is what you have got. Now, yeah, then it is correct. X sin x plus cos x plus log of sec y is equal to c1. That's your answer.
Yes, ma'am.
Yeah, right. So this integration, let's see. So here you have to use by parts rule and you will get x as it is. Yesterday I told you how to use by parts rule. First is that it is first integration of cos x sin x minus derivative of x is 1. One more integration of sin x minus cos x. I am not writing plus. What is the derivative of cos y? If you want, you can directly write log sec y also. But I generally use the integration formula of f dash of x upon f of x dx is log of fx. So derivative of cos is minus sin. So add that minus sin sin y upon cos y dy is equal to c. This is the reason. So x sin x plus cos x minus log of cos y is equal to c. But if this is not there in your option, again now since if it is an MCQ exam, this minus sign is not there in the option, what you have to do? X sin x plus cos x plus log of cos y. Yeah. Should I write directly sec? But because this will become to the power minus 1 means 1 by cos and 1 by cos means sec. Is equal to c. That's your final answer. Okay, everyone? Here?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
So now you try the second one. Second one is more easy than the first one. You should already understand what you are doing.
मैम EY से मल्टीप्लाई करना होगा ना e raised to y से.
चलेगा, वो भी चलेगा. या फिर
Ma'am, e raised to y equal to a raised to x plus x cube by 3 plus c.
correct. That's right. E raised to y minus y is common this here. I can separate out this as
हाँ
e
मैम
raised to
वही
x.
आया e raised to y से मल्टीप्लाई करके
Correct. Correct. Yes. That's now you separate. This is a function in x. This is a function in y. So take along with dy. You get e raised to y dy is equal to e raised to x plus x square into dx. Do this integration plus c is the final answer. So what is that integration? E raised to y is equal to integration of e raised to x is e raised to x plus x square by integration x cubed by 3 plus c. That's your final answer. Everybody got this?
Yes, ma'am.
Yeah. So that is direct variable separable. It is direct variable separable. Now the other type of variable separable is by substitution. So have you completed everything? Everyone?
Yes, ma'am.
Okay.
No, ma'am.
Please
Yes,
write it. Please write it first. I'll wait for 2 minutes. So you can see maximum most of the time pi parts rule and u by that f dash y f of x. That type of that formula will be used many times. So be thorough with that.
झालं ma'am.
Okay, fine. Everyone, and please be
Ma'am.
attentive. Yeah.
ती एक स्टेप सांगता का
Quickly.
इथं राईट हँड साइडला वरती आपण एक्स कॉस वाय प्लस साइन वाय डिवाइड राईट साइडला बघा आपण dx cos x लिहिलं इंटिग्रेशन.
हाँ. तर पहिल्यांदा मी cos y ने डिवाइड केलं. sin y ला cos y ला आणि इकडे dy by dx असतं राईट. पण तो dy मला फक्त y च्या टर्म्स बरोबर ठेवायचा आहे आणि हा dx मी इकडे घेतला. आणि इकडे घेतला तर तो 0 बरोबरच मल्टिप्लाय होणार ना. सो इट विल बी 0. सो इट इज x cos x dx हा sin y इकडे आला into dy. is equal to 0.
ठीक.
Okay. Separating out the variables with the derivatives. ठीक है?
हो.
Yeah. So let me go to now type 2. I am doing 2 examples because more examples will be done on the flip chart. Okay. So let me take one question now. You tell me how you are going to go about it, and then I will give you one more homework. dy by dx is equal to 10 square of x plus 1. This is the differential equation that we want to solve. How will you go about it? It's quite simple. Not again.
X
If
plus y
that
substituting as t.
X plus y is taken as u.
correct. If that x plus y was just x, it would have been very simple. That means I will try to remove that x plus. I put that x plus y as a new variable, and you get variables separable in terms of some two new variables. Y and x name, but the new variable is taken. So what we this is called as function is called as reducible to variable separable by substitution. Okay, so put x plus y is equal to u. If you put x plus y is equal to u, the only step which is you have to be careful is differentiation. You want dy by dx, and now you will get something like du by dx. You have to differentiate. ये equation का आपको x के साथ differentiate करना है. So differentiate with respect to x, you get negative of x with respect to x is 1 plus dy by dx is equal to du by dx. Why I am doing this step? Because I should get the value of dy by dx. What is dy by dx? It is du by dx minus 1. Okay, so you use these two substitutions in one. Therefore, 1 becomes, what will be the value of 1? 1 becomes du by dx minus 1 is equal to x square of new variable. So now what is the differential equation? The differential equation is in new variables u and x. Is it okay? Y is removed. We are going to solve it for u and x as variable separable, and then we are going to back substitute the value of u. So what is this? Simplified to du by dx will become equal to 1 plus x square u. And what is 1 plus x square u? Secant square u, which is now variable separable. Yeah. So du by sec square u means cos square u du is equal to dx. Is this clear? This step is there. 1 plus tan square is sec square u. I took sec square u down. So du by sec square u is equal to dx cross multiplying. But 1 by sec square is nothing but cos square. So one का सदैना I have written two steps together.
Yes, ma'am.
So now just do integration because it is not once. Because it is variable separation. How you do integration of cos square?
1
By
plus cos.
using
We can write
formula.
cos to theta. Cos to
Cos
theta
square
formula.
u is equal to
Cos
cos
to
2
theta
u
plus
plus
1
1
by
by
2.
2.
Correct. 1 plus cos 2 theta, that is cos 2u divided by 2 du is equal to x plus c. So that 1 by 2, is it okay? What is the trigonometric formula?
Cos 2 u is equal
2 cos square u minus 1 is equal to cos 2.
cos 2 u.
This is the trigonometric identity which we are using. Okay. And now you simplify because degree 2 integration is not possible till now. So we are going to convert it to degree 1 and then do the integration. So 1 by 2 integration 1 by 2 du plus cos 2u du integration is equal to x plus c. That is half into integration of du is u plus what is the integration of cos u?
Sin 2u by 2.
Sin to u.
Sin 2u by 2. Correct. Is equal to x plus c. Now two things you have to do is you have to back substitute the value of u. Before that, see whether you can remove this 2 so that it becomes simply this 2 will go that side and you will be able to simplify it easily. Can you remove that 2? Should I have this part?
Yes, ma'am.
Yes, ma'am.
Quickly let me do that. Half as it is, u as it is. What is the formula of sin to u? It is 2 sin u cos u divided by 2 is equal to x plus c. So this 2 and 2 will get cancelled. This 2 which is common will go on that side and we will get u plus sin u cos u is equal to 2x plus 2c. That 2c again can be written as
C1.
c1. Yeah. So that's substitute the value of u now. U is x plus y. So x plus y plus sin x plus y is the cos of x plus y is equal to 2x plus c1. Now this x and that 2x will get cancelled and the final answer will be y minus x plus sin of x plus y cos of x plus y is equal to c1. This 2x I put it on left hand side, it became minus. Okay, so this is your general solution of given differential equation. Yeah, everyone.
Yes, ma'am.
Yes, ma'am.
So I'll give you one question for homework and then we'll stop. Just try to solve this.
Yes, ma'am.
Tomorrow I'll ask you. Take up. Solve the differential equation. Solve the differential equation 1 plus e raised to x by y dx. 1 plus e raised to x by y dx plus e raised to x by y. E raised to x by y into 1 minus x by y into 1 minus x by y dy is equal to 0. One plus e raised to x by y dx plus e raised to x by y into 1 minus x by y dy is equal to 0. So first of all, is this the first order differential equation? Nxy into dx, nxy into dy is equal to 0. So this is first order for the differential. Now we have done only variable separation or reducing to variable separation. X by y is in power of e, so I cannot separate out them. So there will be some way of converting it to separator by substitution. So clearly, which is the term which you can see everywhere?
X by y.
X by
So
y.
everywhere it is x by y. So the substitution will be put x by y is equal to u and then you try to get the solution. So tomorrow I'll ask you this as the first thing, what is the solution of this? Okay, and then we'll work it. Fine. Today, immediately, 3 to 4 students who are there who are going to give the flip classroom, you wait, I will share the topics that you will do. Okay? Clear to everyone?
Yes, ma'am.
Any doubt in today's any topic?
No, ma'am.
No, ma'am.
Okay. Just a second.
Ma'am.
Yeah.